So it's bound to happen, particularly if you have a large format printer. You have been printing something for days. You have a lot of filament invested in this, and more importantly, at least for me, you have a lot of time invested in this, and mere inches from completion, the print fails. Whether the filament snaps off, which is what happened in my case, your filament detection fails if you even have filament detection, or you simply run out of filament mid-print and now you have pretty much a wasted piece of plastic here. So what are you going to do to recover this print? Is there even a way to do that? Well, that's what I'm going to be talking about right here today on Kersey Fabrications. Let's go. So here I am. As you can see, this is my felt print. I was printing this beautiful helmet. Everything is beautiful on this. You can see I have successfully actually switched filaments here twice without any issues on this printer. And then out of nowhere, I put on an old spool of filament and I cracked the filament. It just broke mid-print, just like that. And then I end up with a dead print and I have to recover this somehow. Otherwise, I've wasted what is probably about 1 kilogram of filament here. And honestly, this is 4 to 5 days worth of printing. So I really want to recover this if at all possible. So the first thing we need to do is we need to figure out what layer that we failed on, or more specifically in this case, what the layer height was that we failed on so that we can recover it. Now, in order for this to work, it is really important that you have saved off your major prints before you started. So if you have resized this print, if you have re-angled this print, please make sure you go and tell your slicer that you want to save this off. Save it as, like in Cura, it's a 3MF file. Save that off, because if you do, this makes it really a whole lot easier to save. Otherwise, what you're going to be doing after the fact is trying to figure out the right angle, the right scale, all of that before you're able to, particularly if I want to save off the support settings and things like that so that I can reproduce this in the future. So like I said, the next thing we want to do, we need to figure out what height that we failed on so that we can begin printing at that height again for the remainder of this print. So first thing, if you don't have a large caliper, then you can just start with a large precise ruler. And in particular, I think you're going to want a ruler that starts on 0, just as you see with this one. You're not going to want a ruler that you're having to guess or remeasure how much to take off. This is ideal for this situation. Next up, I have not removed this print from the print bed, adding additional height that may come from the de-seating of this and everything just getting out of whack. I've left this print alone since the failure. So if you only have a ruler, you can obviously just stick it down into the print and do your best by putting it up to the edge here, guessing what you think is the closest layer to our failure. So for this, it's going to be about 24.6 is what I'm guessing here, a little bit over 24.6. And, you know, I'm doing my best to level this so that it is perfectly vertical or at least perpendicular to our build plate. And I'm going to guess that it's about 24.6. Now, to be more precise, it's really nice if you have a large caliper. In particular, this is a 12-inch or 300 millimeter or so caliper that I can use for this purpose. In that case, I am going to simply zero this out. I am then going to pull it all the way out so that I'm using this back part of the caliper, as you can see, the part that sticks out the back. Then I can stick it all the way down, push this down, and I can find out exactly what layer I was on. So this is reading more around 247.10. Oh, sorry, I can push it down a little bit further. 246.5. I'm going to do it again because obviously measurements can change and I need it to be as precise as possible, at least to the 1/10 of a millimeter, which is what our layers are particularly based on. Again, I'm going to do that again. I'm going to push down as far as possible, and I am at 246.99, and I can measure in multiple places to try to get the best answer possible. 246.4. I'm going to get a you know, mixture of different numbers, it appears here. 247 again. So we are just about at 247. So I think 247 is going to be our best estimate at where this stopped. Now, it's not going to be perfect. To guess exactly where this failed, particularly if there's a little bit of leftover filament on the top of these layers, is going to be very difficult. So along with that height measurement that we just got, there's one other measurement we can use to help calibrate the exact height that we were at when this failed, and that is either the X or the Y width of the model, so that we can calibrate that along with the height. Now again, I'll show you this in a minute when we actually go over to our slicer, but what I want to do, I want to measure the width as close to the actual X or Y dimension on the model so that I can use that in my calibration setting. So I'm going to go right here, I'm going to say from a ruler perspective, and I'm going to try to find my widest point. And the widest point here to me looks like it is about, and it looks like 17.7. Let's go with 17.7. And let's try to get a more accurate one using our calipers. So it's actually closer to 180 according to our calipers at its widest point. So 180 millimeters is what we're going for on our width. And like I said, 270, what did I say, 279, I'll look back at the video if I have questions. 279 for the height. And we will use those to calibrate our settings in our slicer. So let's move over to the slicer on the computer now, and I'll show you how we're going to use those numbers. All right, so here I am at the computer, and I'm going to show you two ways to do this. I'm going to show you what's the easy way, and then I'm going to show you what's definitely the more involved way, but possibly more accurate. So let's take a look at both of these. So first of all, I originally sliced this file in the Creality slicer, which is basically just a reskinned, slightly modified version of Cura. So if you've seen this before, it's probably Cura. So we're going to open this up, and we're going to open again that original 3MF file that I saved from my original. So I'm going to open that up. I'm going to open it as a project, which will bring in all of my settings as well, so that when I go to slice this, I actually get all of the original settings that I had with this print. So here I am with the Nikko Industries Deathstroke Samurai helmet, which is what I'm trying to repair. As you can see, all my original settings were captured here. I've got all my support blockers and things up here that were on the original model. And of course, I've got my printer settings over in this area, which were also saved in that 3MF file. Now, what we want to do here for the easy way of doing this is simply to lower the helmet to the point where the only thing sticking out is the part of the helmet that we need to recover. So when I started off, I did all of those measurements, and I came up with what I thought my Z offset was going to be, which is about 247 millimeters. Well, that's going to be a negative number here because I'm actually going to try to drop this down below the bed. So that's negative 247, hit enter, and that should reposition this down just like that. Now, what this means is that this will print exactly where the other one would have printed on the bed, just on the bed level. And so now we can do a preview, we can do a slice, and now that it's sliced, you'll notice I get exactly what I'm expecting, which is just the top of that model and the G code for that. Now, one thing I would recommend, if this is what you end up with, I would probably remove this brim and turn that into just a skirt. And the reason for that is we want that to be as clean as possible when we're putting it on top of that other model. Okay, and so when we do that, we end up with something like this, with just the supports where we need it, like in this area, and then this can finish just as if it would before. Now that's the easy method, and this may be what you want to go with. Now there's a more involved method that I'm going to show you that involves Mesh Mixer, where we can use that X measurement as well to try to figure out as close as we can to where we left off. So I'm going to reset this model. All right, for the next piece, even though it's a bit painful, one of the things we're going to have to do is remove these support blockers from this particular model, because when I do my STL export to get it into Mesh Mixer, then this is going to export as well, and we don't want that. So first thing I'm going to have to do, go to support blockers, which is all of these little squares under here, and just get rid of them one at a time. I won't belabor this, and I'll be back in a moment with these all removed. Okay, so all of those have been removed. So the first thing we're going to want to do now is take my modified STL, modified meaning I have put it in this particular orientation and that I have scaled it up. So we're going to need to export this, and we're going to export it as an STL binary. And this file name's as good as any, and I'm going to go save, and that will save to our disk so that we can import that into MeshMixer. All done. Minimize. I've already got MeshMixer open here. I'm going to do an import, and then I'm going to import that STL into MeshMixer. Go ahead and maximize as soon as it generates that mesh. All right, so here we are. That is my model, just the way I exported it. Now, this one is going to be a little bit more involved, but I'll walk you through it. So the first thing we need to do is go into Edit, and then we are going to do a plane cut. Now, plane cut's going to already be in the mode that we want it to, cutting along the axis just the way we want it, but we just need to now move that plane up or down. Now, if this isn't the correct snap, if it's not snapping to a number that's small enough, which is definitely true in my case, while holding down the blue arrow with my mouse, I can use the up and down arrows on the keyboard to increase that snap. And you'll see here it's getting smaller, and as it gets smaller, I get more fine-tuned control of that arrow. So now I can go in and set it to as close as I can to what I think is my target height. My target height being about 247 millimeters. Zoom in so I get a little bit more fine-tuned control. There's 247. Okay. Now at this point it's exactly the same as what we did in our slicer, so we haven't done anything more. We can go ahead and accept that, and notice I've got cut, discard half. Notice the see-through one down here is the half we're discarding because we don't need that, and we're going to remesh that fill. We're going to accept that. Now that gives us just the top of the head right there. Now what I want to do is let's find out if that width that I talked about before, which in my case is somewhere between 177 and 180 millimeters on that width, it's that the correct width. Does it look correct? So I can come in here and I can go to Analysis and I can go to Measure. Now measurement is going to be in the X direction, and then type, I'm going to go from the outermost part of the object to the other side of the object, as you can see right here. Now I'm going to go up here and I'm going to start measuring along here. Now if I hold it down, I can sort of see the different measurements as I move around. So notice I'm about 175, and do I really get much more than that? Let's see. But see, I don't really get much more than 175, which is really not in the range that I expected. So I may have cut this too high, since I'm really not seeing the width that I was hoping for. So what I'm going to do at this point, since I don't think that I really cut this far enough down, because even at my max width I'm not hitting where I thought I should, I'm going to undo. That puts that back to here. And then I can move this down. And so what I'm going to do now, let's go ahead down to 246. All right, now 246, I'm going to accept that, which is going to recut the model. I can go to Analysis again and Measure. All of these settings should be the same. All right, and then I can go and try that measurement again. Of course, I have to see that red line go all the way across the model in order for it to be an accurate measurement. So that is getting a lot closer. I'm at least at the 176 mark. Notice that this is keeping track of my max and my min. The top number here is my max. The bottom number here is my min. So what I'm looking for is this max number being somewhere in that 177 to 180 range. And I can get it just about to 177. But that's about it. So I could even take this down a little bit further if I think I'm really still not quite where I want to be, or I can call that close enough and give this my first test try, which is what I think I'm going to do, because this is kind of lying in the middle of where my measurements were. So I'm going to go done, and then I can do file, and I can export this. STL is what I'm going for. Make sure I'm in the right folder, and then I can export it to one of these names. Let's just call this Deathstroke Samurai Helmet Repair 00. Click Save. All right, minimize this. Go back into our Creality Slicer. I can clear this. Now let's import that new STL. There we go. So now I have this model right here, and I can go put back in all of my supports if that's what I need to do on this model. I'll go ahead and slice this. Then I'll meet you back down at the printer where I can show you what we're going to do next. So here I am back at the printer, and as you can see, I removed the damaged print from the bed, and I'm all ready to go. I'm heating up as we speak. Then what I'm going to do, I'm going to load up some fresh filament and begin that print that we just sliced. But the key here for this first print is I only want to let it print enough layers for it to be rigid enough for it to hold its shape, so I can pull it off the bed and then test fit it to our original model. And again, we may be only talking about a few millimeters, half a centimeter or so of actual layers before I can actually pull that off and test fit it correctly. Then from there, we can iterate on that. We can either raise or lower our starting layer to get just the right fit to our original model, so that there's less work when it comes to reassembling everything. So like I said, I'm going to get that going right here, and I will be back in just a minute when it is time to pull those test layers off. Okay, so I've got about 5.6 millimeters, I think, on this print, and that's what I'm going to go with for my testing. Now, I hope I've given this enough time to cool, but I probably haven't, so let me see if I can get this off of here. There we go, so it did come off. Now, I can tear off these little pieces. Looks like a pretty good chunk, about 5 millimeters tall, so let's see how that fits the original bucket I have here. See if that fits well. So, fitting it on here, I'm going to feel the outside and the inside to see if I like the way that it fits, or if I need to change the height a little bit. This is very, very close. But I think that might be good. Okay, so I definitely think that's close enough. I think that any other issues that I have with it not being quite perfect will be able to be sanded down or puttied if necessary. So I'm pretty happy with that. Between the two measurements I did, I was able to get really close to where this print failed, and I think that this is going to be a nice seam when I get everything put together. And I'm going to go with this. So the only thing left to do for this print is to print the full piece, which I've already got on my SD card. So it's time to get started on that. And it's still a pretty long print to get this one done, so I will see you tomorrow. Okay, so the replacement print is all done. Let's take a look at how it turned out and then do a test fit onto the original print. So first of all, I got to get this off of the build plate, which may be more easy said than done. More easily said than done. And there we go. I did get it off. Luckily there was this little piece on the back. So inside looks like garbage. It's about what I expected because I didn't fill it with supports. This will all clean up. After all, it's the inside of the helmet. I can take care of that later. But what's important to us, let's see how this all fits together. There's our original print. And let's get in close real quick and we'll see how it fits. Okay, so here's the bucket. Let's throw on the new piece and see how it looks. So if everything went to plan, and it looks like it did, it should line up all the way around. And I've just got the slightest of overhangs here, which is going to be really hard to pick up. But as you can see, I have repaired this print, saved days worth of printing by just reprinting the cap of this helmet. And I think that looks really, really nice. So what I want to do now is go ahead and grab some glue. I think I'm going to get some 3D glue, which is excellent for PLA. And we will stick this back on here and give you one last look at the finished piece. All right, so that's about it for this one. I'm really happy with the results. It was a really wonderful thing to be able to show you how I recovered this print because it's a beautiful print, and I'm going to be showing you more about this one in a future review of this particular printer, the Ender 3 Max. So if you want to know more about this particular print, wait for that video, and I'll have that up here soon. Now, if you're interested in this model, this is the Deathstroke Samurai Mask by Nikko Industries, and I will provide a link down in the description where you can purchase this mask / helmet from him. And it's a terrific model as usual from Nikko Industries. Now, as usual, I want to thank all of my Patreon supporters for allowing me to make this video. You will see them coming up here on the screen because I like to give them credit for all they do for this channel. Now, if you haven't already done so, go and click the little subscribe button down below. It lets me know that you're enjoying this content, and it really helps with the channel's overall growth if you want to keep seeing content like this. Now, I really hope that the methods that I showed you in this video today help if you ever run into this problem. Now, if you have any other common issues like this you would like to see addressed on this channel, go and leave me a comment down below. And obviously, if you have any other suggestions for problems like this one where you have failed prints, go ahead and leave those down below, and members of the community can take a look at what your thoughts on what I offered here today and things that you've done in the past to get around this yourself. Now, I've recorded this ending 50 times and I can't get it quite right, so I'm going to cut it off right here and say, I'm Chris, and this has been Kersey Fabrications. I'll see you next time.